Okay then? Good. Next. Okay. Okay, so we're going to introduce a new idea. It's kind of a simple one right now, the idea of proportions. So it comes from a statement like this. 62% of mothers want increased athletic programs in the schools. Alright, so this should seem like a fairly common sort of statement that you would hear. Comes from someone, for example, taking a poll. So how do we translate this into statistics, language and notation? First of all, what do we do with that 62%? How do we rewrite that? We write this as a decimal number. It's 0.62. That's the first thing. Next, this is not a statement about means, which is all we've talked about so far. This is now initially it's a statement about percentages, but in statistics we don't call them percentages. These are proportions. Oops. So the next thing is, just like with means, you can have a proportion for the population, and you can have a proportion for your sample. So if you're going to make a statement about a proportion for your sample, what's the notation for that? Well, first of all, what letter do you think we use for proportion? P. Awesome. So proportion for the population is P. Okay. Now, how do we write down proportion for a sample? Right, like this, we call that P hat. Alright, so let's put this in action. From a census, 51% of U.S. residents are women. How do we write this in notation? Yep. P equals 0.51. Good. Now, what proportion are men? Right. So how do we write that down in stats? Let's say 1 minus P equals 0.49. Because how did we get 0.49? Yeah, do 1 minus. Because presumably whoever's not a woman is a man, so man is everyone else. Or men represents everyone else. Okay. Next bit. From a survey of 1,000 teenagers, 673 like Justin Timberlake's music. So how would you write this down in notation? Okay. So really nice. How did you get 0.673? No, it doesn't. Uh-huh. Okay. Well, okay. So you're half, okay, yeah. It's a survey, so yes, it'd be, first of all, it'd be P hat. Now, second of all, you're right that it's 0.673, although the way you got that was a little not quite there. 673 out of 1,000.
You just want to find the rest that don't like it, you would, if that's like, you would subtract it?
That's funny, that's my next question. Alright. But I just want to point something out. When you write this down, you would never ask, first of all, you would never say 673. Because it doesn't make sense to ask. You wouldn't say, what is the average number of people who like his music? It doesn't make sense. How many people like his music on average? What does that mean? But what does it mean to say how many people like this music on average? It doesn't make any sense. It only makes sense to say how many out of a certain number. That's a proportion. Now again, we're used to thinking of these things as percentages, so you might make the statement that I did a survey and 67% like Justin Timberlake's music. So if you're gonna express this in English, it's okay to use percent. We're gonna be doing math, and we're gonna be doing calculations. So for all those purposes, you should get used to thinking of all these things as decimal numbers. And in particular, this is again, even though you see the number 673 and 1,000, what you need to find here is a proportion. And remember that a proportion is basically is a fraction, so it's going to be a decimal number. 673 out of 1,000. Okay. What proportion of teenagers do not like his music? Oh, Chastity, I think you're about to tell me that. Or who was about to tell me that? You were about to tell me? Oh, Violet, yeah, you were about to tell me that. Right. Right. And that gives you 0.327. So note that you can either be given a proportion, as in the U.S. residents or women, P equals 0.51, or you may have to figure out what the proportion is. 673 out of 1,000. You dig? So again, that's what a proportion is. You're probably more used to thinking of it as percentages, but you're going to have to switch over to think of it as proportions using decimal numbers. Okay. Now, everything that we did previously when talking about means, we're now going to say how do we do all those things, but with proportions. So one thing we have to ask is, what is the mean for p hat? Sorry? Can I say this? Okay, so remember, because you weren't here last time. Yeah. Last time was really important. So in the same way that last time we talked about the mean for x bar, now we're going to talk about the mean, but for p hat. And remember, the mean for x bar was really simple? Yeah. It's going to work very similarly for the mean for p hat. It's just p. So what's the next thing we need to ask about? Yeah, what's the standard deviation for p hat? Now, what do you think the notation for this is? Same thing, how would you say it? Sigma sigma for what? For p hat. Okay. Now, the way we write down stuff is different, so the formula is different. And there it is. Okay. So sigma for p hat is take p times 1 minus p over n, and then square root the whole thing. So there's mu for p hat, there's sigma for p hat. What's the third thing we need to say? No X bars. What's the third thing we need to discuss? Yeah, is it normal? Exactly. So it turns out this is the test to see if the distribution is normal. If np times 1 minus p is greater than or equal to 10, then the distribution of p hat is normal. Because. Just because. Yep. It's normal if you have np times 1 minus p is at least 10. N times p. Okay. Okay. So, armed with these formulas, now let's tackle some problems. Alright. So, 17% of Americans have high cholesterol. Suppose we take a survey of 80 people. Well, let's ask these questions. What is mu for p hat? You're partly right. Mu for p hat. That's a little. Is what? Yeah, it's 0.17 because it just comes from p from the population. So it's just 0.17. But it's already given as a proportion. You don't need to find it. Does it say? It doesn't say such and such people out of such and such people. It just says it already says 17%. That's already the proportion. Does that make sense? Okay. Right. Well, now we come to the part where you have to do some figuring. What is sigma for p hat? Yeah, so now we have to use this formula, which was p 1 minus p over n, square root the whole thing. So in this case, what is p? 0.17 times 1 minus 0.17 divided by what?
80.
Divided by 80. That's it. So you crank this out using your calculator. I'll show you how to do this just using the spreadsheet. I like to do everything on I like to use the spreadsheet as my calculator because I already have it right there. Okay.
I can
So
do that. I can find it.
you just use the spreadsheet itself. Okay. So how do you type this in? Well, you have to take the square root, so it's SQRT parenthesis. There we go. What? 0.17 times 1 minus 0.17 close parenthesis 1.17 divided by 80. Close your parenthesis, and there's your answer. $4.20. Okay. So you get 0.0420.
And that was SQRT.
The command for square root, SQRT, right? Okay, so there's your sigma for p hat, and the third thing is the distribution of p hat normal? So how do we check that? So how do we check? Right. So you need NP 1 minus P is greater than equal to 10. I'll put a question mark there because I don't know if it's true or not. So what was N? 80. What was P? 0.17. 1 minus 0.17. Is that greater than equal to 10? So let's do the calculation. 80 times 0.17 times 1 minus 0.17. That gives me 11.288.
No.
So is that greater than or equal to 10?
Oh, no.
Yes. So it's normal, so we're good. Okay. So
how would you get it to be less than 10?
if it's less than 10, we're going to say that the distribution is not normal. And at this point, we wouldn't know what to do. Right.
Can you put on a lower one up here? You just put it on
Uh-huh. You can use a calculator. No. What'd you get?
I got roughly 0.1411 divided by 8.
What'd you get as your answer?
0.0015.
Okay. And what did you forget to do? Right. Okay. So now that we've got these things in hand, what's the probability that less than 12% of your sample has high cholesterol? So first of all, let's write down in notation what this question is asking. What is this question asking? Right. How do we write this down in notation? Right. So wait, I should say which P, because now we got a bunch of P's. P, so P meaning what to start? Yeah, because there's a probability, so there's asking for probability, so probability that, now what? Something less than 0.12. Well said. Question is what? Is this a question about X? What is less than 0.12? Not S. What from your sample?
The sample from the sample.
The or to say it with a little more clarity, are we talking about, normally we would write down something like X bar. But is this question about a mean? Yes. Chastity coming up big. Why P hat? What does P hat mean?
I mean for the sample.
It's the proportion of the sample. And that's what we're talking about. We're talking about from a sample, and 12% is a proportion. So it's P hat. So this is what this question is asking. Proportion of a sample. So sorry? No. There's one sample. Right. But I mean, within your sample, some people will say yes, some people will say no, for example. And that's how you find your proportion. Okay. So now what do we do? We're being asked to find a probability, so what do we do? Right, we draw a picture. Now, let me just remind you in general, when you do a problem like this, the first thing you'll have to do is find your mean, which we already did, find your standard deviation, which we already did, and say, is it normal? Which we already did. Since we know it's normal, what kind of picture can we draw? Yeah, we can draw the bell curve. We can draw it because we know it's normal. You have to check first. So let's do it.
How do you know it's normal?
So what if it wasn't normal? What kind of picture would you draw?
You would stop and say, I don't know.
How is it normal?
That's it. How do we know that it's normal? What do? We do that check, which I just told you about 5 minutes ago, which is this. Okay. So here's the picture. What do we put on the picture? 0 goes in the middle for Z. What else do we put on the picture?
Point 12.
And where does point 17 go?
Underneath 0.
Right. And how do we know that point 17 goes there? What do we know about point 17? That's the mean, exactly. And how do we label that? How do we label that row? Yeah. These are p hat values. Exactly. Okay. Now what else should we put down there?
Point 12.
Yeah, point 12 is the value that we're looking at. And what should I do? Shade to the left of point 12, because that's what the question is asking about. That's it. So what's the next thing that we do? Let's find the z-score. So what's the z-score? Right. When you're finding the z-score, which goes first? Right, your data value. And what goes second? The mean. Right? We just said that 0.17 is the mean. Okay. And then what do you divide by? The standard deviation. And what's our standard deviation?
0.04.
There you go. Okay. So now we have to work that out. That's negative 1.1905. So we can now fill that in on the picture. Now that we have the z-score, what do we do? Now what do we do? Okay. So, yeah, let's for practice, let's go ahead and use stat disk. So what do we do? Here, here, here. And what do I punch in? That's my z-score. And what do I need? Area to the left. It's right there to 4 places. 0.1169. Okay. And so the answer is use Excel. Norm S dist of negative 1.1905. Okay. The better you get, the faster it goes. The more experience you have, the faster it goes. Okay. Now I want to point something out to you. You guys are incredibly clever, because I didn't even tell you the formula of how to find the z-score, but you did it anyway. Because this is a new situation, but it's the same idea. So, So really, what's the formula? So point 12 is what's that? What is that in notation? That was our p hat value. Now point 17, what was that? Right, and what's the notation for that? That was mu for p hat. And then we divided by what's the notation for that? Sigma for p hat. Exactly. I didn't even tell you guys what to do, but you figured it out because it's the same idea from before. So gold star for you. All right.
Extra 5 points.
So right. So do you guys see how the formula is different, but it's the same?
Yeah.
All right. Good. Okay. Any questions about doing this problem? We will? Okay. So I want to point some things out though. There are a lot of decimal numbers in this problem. All right. So just in notation, we're dealing with proportion values, p hat, and there's also 1 minus p hat. Now there are also probability numbers. Now, in this problem, 0.17 is what kind of number? Is it a proportion or is it a probability? 0.17. I'm hearing mixed. 0.17 is a proportion. What about 0.12? What do you think? What is 0.12?
Oh, probability.
.12 is a proportion because what are you talking about? 12% of your sample. That's a proportion. What is 0.1169? Y'all? No, it's whatever you say, and hopefully you'll say it right. But what is .1169? Yeah. If you like, you can say, okay, it's an area, but what is an area? It's a probability. Alright. So, when you're doing these proportion problems, it's going to be really, really important to keep track of what's what. It's no longer quite as clear. When you have x bar equals 64, no one's ever going to say that 64 is a probability. That doesn't make any sense. But when your proportion is 0.17, if you're not keeping track, you could easily slip and think that that's a probability at some point. So keep straight which is which.